Morning everyone. We started yesterday with module 2 linear filtering methods based on DFT. So in that we have taken the first method as how to compute the filter output by using DFT IDFT method. Okay, so you just to recall, so whenever two sequences are given, okay, so first we will calculate what are their lengths. So according to linear convolution, the length of the output sequence is L plus M minus 1. So now in this case it is 3 plus 2 minus 1, 4. So now as n is equal, the length of the output sequence is 4. Okay, so then we will append zeros, corresponding number of zeros, so that we can make x of n and h of n length both equal to 4. But because this is a requirement whenever you are using DFT and IDFT method to calculate the result of the filter. Okay, so therefore accordingly, after fixing the n, we calculate what is x of k, h of k, and we are getting the product also, x of k into h of k. Then later on we are taking the IDFT of that particular product, and that IDFT sequence is nothing but y of n, which is nothing but output of the filtering operation also. Okay, so therefore these steps are going to show you the calculation that we did yesterday, and y of n is equal to finally 1 1 minus 1 minus 1 was the result. And this y of n is nothing but it is actually the output of linear filtering operation, which is carried out through DFT process. Now just to verify our results, we have done a simple linear convolution also by using our conventional method, that is keeping one sequence constant, other sequence is reversed, later on it is gradually shifted by one place, and every time it is shifted we calculate the product, and finally we add them if more number of samples, more than one multiplication is there, and we are going to get the corresponding sample values. Okay, so therefore I can write totally y of n is equal to y of 0 1 2 3 as the samples which are present in the output sequence. And so here also we have verified in the last class that so the four values, they correspond to the same 1 1 minus 1 minus 1, which is a result calculated by the DFT IDFT method. Okay. So now there was a one question that always x of n, h of n need not be 3 and 2. Okay, so their length may be different than 4. Okay, suppose if length is more than 4. Okay, so then in that case what we have to do, suppose we adopt this method x of k and h of k, that is calculating DFTs IDFTs, then what is the way is you will have to write a big matrix so that you can multiply such a lengthy sequence with it. Okay, so that would, otherwise we will have to go for the equation method, so you will have to write those many number of equations and solve to get the DFT samples, and later on after getting x of k h of k values, then you can multiply, and again while doing the IDFT also you will have to write either equations or the big IDFT matrix only to get back y of n. Okay, now in order to simplify that process, we also have another alternative also, and that is provided by through circular convolution. Okay. Am I audible clearly?
Yes, ma'am.
Yes, we'll continue. Okay. So therefore, through circular convolution also it is possible to get the same result. How it is, let us see in this class now. Okay, so for that I have given the title as, you can also write down as a part B operation. So for part A, later I will share this page also. So part A I have taken what? Linear filtering by DFT IDFT method, and this example we considered in the last class. It is not 3, 1 to 1, it is 1 to 1. 1 to 1, and we took it for I think 1 minus 1, 1 comma minus 1. So for that it was the result. Okay, so I told you to change this particular data, that is the sample values, and do it again. So anyway, today also we will continue with the same example only. X of n 1 to 1, h of n 1 and 1 minus 1, 1 minus 1. Okay. So with the, for the same samples we are going to verify our results by an equivalent method, Okay. I was discussing about this title. Okay, so here I have mentioned particularly that it is DFT IDFT method. That's why we are going to calculate this x of k, h of k, y of k, and all. Okay, so now what we discuss is through circular convolution how it is possible to obtain the same result. Okay. So now, So here again I will take the same the input sequences which are actually the inputs for me for the operation. So x of n is again 1, 2, 1, and h of n is 1 comma minus 1. Okay. So you can do for other also, but let us verify for the same data 1 minus 1. Okay. Now, so when these two are the sequence, I hope you understand what is x of n and h of n. Okay, so x of n is the input to the filtering operation, h of n is the impulse response of the particular filter. Okay, and for this y of n is what? Y of n is the output sequence. Y of n is the output of filtering operation. Okay, so through block diagram also you can represent. In that case, what you have to do, write a block diagram, write a rectangle. Inside the rectangle you can write h of n, that represents what? The filter with impulse response h of n, and for that box you can give x of n as the input and you can show y of n as the output. Okay. So now let us start with this particular operation. Okay. So again we will calculate. So we will consider m is nothing but what it is from the previous length of x of n, it is length of x of n. Okay, so now in this case it is again 3, and we will take n as length of h of n, length of h of n. So this is again 2. Okay, so therefore length of output sequence will be 3 plus 2 minus 1. Okay, so that will be equal to 4. 4. Okay. Therefore, as our length is equal to 4, then we need to change. Okay, so now even you are doing by DFT DFT method, then also we are making the sequence length as same, and even if you are going for the the circular convolution method, there also the condition is the lengths of both the sequences have to be same. Okay, so therefore now x of n will become 1 comma 2 comma 1 with 1 0, because I have to make the length as equal to length of the output sequence, and length of that is h of n is also extended, and it is now 1 comma minus 1 comma, now it requires 2 zeros. Okay. Now once this is ready, okay, even the same thing we done with the the previous method also. So here also the same method. So here you are using the DFT IDFT matrix, that's why the lengths have to be same. But here you are doing the circular convolution operation, that's why we are making the same sequences of both the sequences of same length. So now while we are already familiar with this kind of representation. So even the circular convolution using tabular method. Okay, so we have adopted the same pattern for representing. Similarly, you are here also you just write down the same table form. And what is y of n here? Y of n is nothing but it is a x of n circular convolution with h of n. Circular convolution with h of n, or you can also write that equation also. Okay. So now why it is possible to use circular convolution? Because we are doing the filtering operation. Okay, so it has been done with the DFT IDFT method also, and now we are checking that with the circular convolution. So what is the purpose? Why the circular convolution is going to yield the result for us? Okay, the reason is we know that the product of two DFTs. Okay, so what exactly is that property? Product of two DFTs is equal to what in time domain? It is equivalent to circular convolution in time domain. This is what is the reason. Why we are going for the circular convolution method for proving the result. Okay, so if you take the product of two DFTs. So this is going to be equal to what? Circular convolution in the time domain. So for this reason, okay, instead of calculating this part, x of k into h of k, okay, so we will calculate this part. Anyway, these two are equal. Anyway, these two are equal. No, so that's why in part A we have tried with this. We have tried with this. Okay, so now in part B we will try with this. Okay, so this particular operation should also yield the same result. Okay, so therefore now take the sequence x of n. So what is the sequence x of n? You just go on solving it. It is 1, 2, 1, 0, 1, 2, 1, 0. So now h of n. Now it is a circular convolution. You cannot write the sequence as it is. This sequence has to be reversed. This sequence has to be reversed in time. So how we are going to do it? What is the new sequence? Actually what we have to write? H of minus n we have to write here. Sorry. How should we write it? Yes. What is the sequence? Can you tell me, anyone? Aishwarya. Aishwarya
Yes.
TC.
Yes, sir.
How to write h of minus n? How to write h of minus n? Now in the circular convolution we have used this already. Okay, you will have to circularly reverse the sequence, and we are circularly reversing about this 1. That is important. So you are circularly reversing our sequence about 1. So therefore this 1 will remain as it is. This 1 will remain as it is. Okay. So the only thing is you have to write the remaining samples in the reverse order, that is starting from 0. Okay. So your sequence will be 0, 0, 1. You can verify with that circle also. Okay. So if you are doing it, draw a circle, go in the clockwise direction. Oh, sorry, it is minus 1. Minus 1. Did you get this? Kirtana? Kirtana? Daneshwari?
Yes, ma'am.
So h of minus n, is this right?
Ma'am, correct.
Okay. So you can do by that graphical method also. You draw a circle. So in the positive direction, that is in the anti-clockwise direction, first you mark 1, minus 1, 0, 0. Okay, and later on you read in the reverse direction. Then also you are going to get the same. Or otherwise, what you can do easily without doing all this, keep this one as it is. That's why I have mentioned it in red. Okay, then this 0, 0, minus 1. Okay, write in the reverse order. Okay, so start with 0, 0 and then end at minus 1. So this is the circularly reversed sequence. Now that sequence is used here to compute the result. Okay, so it is 1, 0, 0, minus 1. So that will become the first sequence here. This will be the first sequence. So now you just multiply. What will be the first one? First sample. Sample by sample you have to multiply. So 1 into 1. Then remaining 2 samples will 0. So last one will also be 0. So y of 0 how much?
1.
1 0 0 0.
Same. Okay, so the first one you are going to get is 1 into 1, it is 1. Okay. Similarly, what you have to do in the next, this sequence will be kept as it is. So this will be 1 2 1 0. So this is not going to change. This is not going to change. So here you have to you have to shift it. Okay, so this will be, first you are going to minus 1, then
1 1 0 0.
0 comma 0. Okay, so here the sample that is generated is, what is that sample?
-1
It is y of 1 sample. What's the answer?
1
-1
-1 plus 2 0 0.
Alla, y of 1 is how much?
1.
-1 2
Alla, y of 1 is 1, no?
0.
Yes, ma'am. 1.
Okay. Okay, just a minute. It's not taking the next row. Okay, anyway, I'll continue here. What can you tell me the next solutions? What will be the next? Like y of 2 and y of 3. You just go on telling me y of 2 and y of 3. So here, so you will have to rotate it one more time.
0.
The sequence will be 0, then
-1
1 comma 1 comma
1
0 again.
0.
Okay. So for that, what is the answer?
-1
-1.
-1. Okay. So the last one. So this will remain same, 1 2 1 0. So this is not going to change here. So you will have
0
to rotate it.
0
Mm.
0 -1.
So
-1.
I'm going to generate 3. So solution will be again minus 1 only. -1 only. -1. Okay. So you just go on checking this. So y of 0 is how much? 1. Next, y of 1 is 1. Y of 2 is -1. Y of 3 is -1. Okay. So therefore, you can write the output. So the result of linear convolution y of n. Now this time we have done with what? By using the circular convolution between x of n and h of n, and this is giving us the result is 1 space 1, and next is -1 -1. So this is what is the solution. Now this solution is same as what we have obtained previously using DFT IDFT method also. Okay, so just go back to the previous 1 1 -1 -1. Okay, the only difference is we have adopted here circular convolution. The reason for using circular convolution is this statement. Okay, so multiplication of two DFTs in the frequency domain is equal to circular convolution of their time domain sequences in the time domain. So because of that reason, part A we have taken as a product of these two, and in the part B we have verified with the circular convolution method. Okay, now if we are adopting this method, in order to generate y of k, you will have to use IDFT also. So we will have to do this IDFT also. See here. Okay, but here the calculation is much simple. You need not go for the complex calculations. You will have to simply perform the rotation of one sequence by keeping the first sequence constant. Okay. So this is a condition when unequal length sequences are considered for operation. Okay. So now this method is most convenient because what may be the reason? The DFT IDFT method you can use very easily if the length here comes to be 4. Now this length comes to be 4. Okay, but if it is other than 4, okay, so then you will have to write another matrix only, or you will have to solve the equations. Okay, so therefore if you are getting this m plus n minus 1, okay, so other than 4 you have to adopt this circular convolution method only, so that will be easy. Okay. So just take another example. So consider your x of n sequence as 1 2 3 2 1. That's sufficient. And your h of n sequence, you take it sometime. For example, if you take 1 2 only, then what happens? 1 2 only. So here m is equal to 4. Okay. Just solve this problem. M is equal to 4 and here n is equal to 2. N is equal to 2. Okay, so therefore your m plus n minus 1 thing. So this will be equal to 4 plus 2 minus 1. So now it will be 5. Now this is 5. Okay. So once, what is this 5 actually? This shows the length of your resulting sequence. Okay. So this 5 is actually what it is? Length of y of n. Length of y of n. What is y of n? It is the output of linear filtering operation. So now you will have to adjust the length of x of n and h of n to this 5. Okay. Therefore now you write what are the new sequences? So x of n is now again append 1 2 3 2. So now make it 5. Okay. So 1 0, whereas in case of h of n, so it will be 1 comma 2, then 3 zeros. Use 3 zeros. Okay. So then to use your what tabular method, you will have to write h of minus n. So further you can solve the problem and verify. So whatever the result you are going to get. Okay. So the length of y of n will be 5 sequence because you have to rotate it 5 times. Okay. So here I will write the minus n. So directly I can write. So you are shifting about this 1. Okay. So 1 you keep it as it is. 1. Now start writing from this end. 0 0 0 2 in the reverse order. So therefore here 0 0 0 comma 2. So that is the reversed sequence. Okay. So now you can write down the table and get the solution. Okay. So I hope this procedure is clear. Yes, you complete this, and similarly you can calculate for the other sequences also. Okay. So now this completes actually the first topic, that is linear filtering by DFT method. So one is directly DFT IDFT, other one is as an alternative using the circular convolution.